Let's talk about trig derivatives. So right at the top of the page here, you can see a refresher of all 6 derivative rules for trig functions. So cosine's derivative is negative sine, sine's derivative is positive cosine, and so on from there. Okay, so we will use these all as memorized facts and do a handful of examples in this video and just sort of weave these into all the differentiation stuff we already know. So my first function here, whose derivative we'll compute, doesn't involve any fancy rules because it's just adding 3 things that have their own rules. So I can go straight to the derivative f prime. I'll have 10 times cosine's derivative plus 7 times sine's derivative, which is cosine. And then finally, we'll subtract tangent's derivative, which is secant squared. Just a note before we continue about secant squared and stuff like it. When we write that little 2 in that spot there, it looks really bizarre because it's just on the secant part, which alone without any input doesn't mean anything. What this notation means is secant of x, the function, squared. So like secant of x times itself. The reason this has kind of become just kind of like the standard way to write exponents on trig functions. So this is true for secant as well as sine and cosine and the rest of them. We put that little number up there. The reason it's become standard is just because it saves you a set of parentheses, right? So when I write it this way, I have an additional set of parentheses on the outside squared, just to make it abundantly clear that it's not secant of x squared. I'm talking about secant of x all squared, right? So putting the 2 there takes it away from the x, so it still theoretically has that clarity, and then just saves you a little bit of writing. If you find it too misleading and just not helpful, you're always welcome to write secant squared as secant of x squared. Instead, just make sure it's clear it's not secant of x squared. Okay, so next example, we'll start to bring in some of the fun derivative rules. We have tangent of x over x cubed plus 1. So we will use the quotient rule because this is division. Right, so I have my f over g and do the quotient rule. The f for the quotient rule is tan x. The g is x cubed plus 1. Tangent's derivative rule is that secant squared from above. X cubed uses that standard power rule 3x squared. So when we put our derivative together, we'll do the quotient rule formula. Low d high minus high d low over the square of what's below. Low d high minus high d low over the square of what's below. So I have x cubed plus 1 and a big set of parentheses squared, and that's my derivative. All right, the next one is a chain rule problem. And this does require some practice here. So we have sine of 10x to the 4th plus 2 to the x. So with this sine of, and kind of as you plug something into the sine function, you get these parentheses. It can be a little misleading to our eyes at first, so we always want to kind of double check before we keep going. These parentheses make it look like it might be multiplication. Whereas, so what's in the parentheses definitely has its own derivative rule. And we're tempted to say sine has its own derivative rule as well, but it's really sine of x, right? This on its own, sin is like the square root symbol. It doesn't mean anything on its own. It has to have something in it to use a derivative. Same thing here. So this is going to be a chain rule, right? This is f of g of x, where your outer function is sine of x. And then what's being plugged into it is that 10x to the 4th plus 2 to the x. So this is being plugged into sine of x. Okay, so once we decide to use the chain rule, we're kind of off to the races here. We have a derivative rule for sine, that's going to be cosine. The derivative of 10x to the 4, we're doing 10 times 4x cubed, so that's 40x cubed. And of course, the derivative rule for 2 to the x is 2 to the x ln of 2. For the chain rule, our derivative formula will be f prime of g times g prime. F prime of g, so that 10x to the 4th is still in there, times g prime, which requires parentheses because it has addition. Okay. So even though this is in parentheses and this is also in parentheses, this is in parentheses because it's being input to the cosine function. And then you have times regular multiplication over here. So we have to kind of train our eyes to recognize that's what's happening because there's no physical difference between the two. Okay, my last example for this video is going to be another chain rule. And this one you can see has a product rule inside of it. But this is, I chose secant for this example to kind of show a little extra weirdness we'll run into here that we haven't really had to deal with other derivative rules. Okay, so we'll start this one the same and then kind of come upon the weirdness that I'm advertising. For the same reason as the last example, we're seeing this as secant of this stuff. So this is chain rule, right? This is f of g of x. So the outer function is secant of x. And then the inner function being plugged into it is e to the x root x. Secant has its own derivative rule. That's secant times tangent. For the derivative of e to the x root x, these are two separate functions with derivative rules multiplied together. So this is going to be a product rule. So I'm going to skip the scratch work for that and go straight to the derivative. You're welcome to check me with some scratch work on this side. So for the product rule, we'll have f prime g plus g prime f. That gives me f prime g plus g prime f. Yep. And of course, you can switch the order within the terms or between the terms here in your mind. Okay, so let's get to the unique part of this problem that really separates it in a big way from the one above, aside from that extra product rule. So we decided we were doing a chain rule. So we're going to do f prime of g times g prime. But what's really strange here is that this f prime has two inputs, right here and right here. So when I do f prime of g, this e to the x root x is going in two different spots. Otherwise, everything works the same. It just kind of, I don't know, to me it feels kind of bizarre. All right, so this looks like f prime of g times g prime, and then we have big set of parentheses, the whole product rule formula from over there. And again, these are in parentheses because they're the inputs to these trig functions. This is in parentheses just to group it for multiplication.